then its outer body is 120. From outside to outside is 120. If it is 120, its inner to inner will be 100. I have written it here. So which measurement we will use for calculating perimeter? We can't use outer diameter 120, we can't use inner diameter 100 because both materials will have changes after rolling. Check here. Here I have written 110. What is this 110? It is in the outer diameter, it is in the inner diameter also. What is this? This is medium diameter. It is in between this wall. If if its thickness is 10 mm from outer body to inner body, its center is 5 mm. From this 5 mm dotted mark, I have indicated it using dotted mark. From this dotted mark to this dotted mark, I have shown its arrow. Wherever arrow starts, that is the indication of measurement indication. So dotted line to dotted line is 110, because outside to outside is 120, we know 120, outside to outside 120, and 10 mm thickness it is having. Outside to outside is 120, same. That picture is this one also. I didn't make any changes here. Why did I write 110 here? Because it is the measurement indicating from dotted line to dotted line, mean diameter line to mean diameter line. So this, whatever I have written here, 110 is correct. Whatever I have written here, 100 is correct. Whatever I have written, 120 is correct. It is indicating outer surface to outer surface. It is indicating same jobs, inner diameter to inner diameter. It is also indicating same measurements, same jobs, medium diameter to medium diameter. So when we calculate, we shouldn't use outer diameter, we shouldn't use inner diameter, we have to use medium diameter. Then we will get the proper measurement. If we use 110 as its diameter, proper diameter, then we can apply the formula pi is equal to P is equal to pi d. P is equal to pi d is formula. Earlier we have calculated one without thickness. We same measurement, same calculation we have to do, but the difference we can find out is dia has been changed. P is equal to pi d. Pi is 3.14 and d is now 110. D is into 120, D is into 100, D is 110. 110 we have applied. 3.14 into 110. If we use calculator and we find out its measurement, we will get 345.58. I have calculated it earlier and wrote that name. Okay, we can check 3.14 into 110. 3.14 means pi. Pi we can direct apply. Just click the shift button. Afterwards there is a indication of pi. Pi. Now pi has already reached pi into 110. Pi into 110 is equal to, we have got the measurement 345.57. 345.57 is the measurement. I have written 345.58. Why? 345.5 after 345.57, one measurement 5 is coming, 51919. If after dotted line, after two indications, if one digit comes, it is bigger than 5, we can write the earlier digit as, we can write earlier digit, making it, adding 1, and then it will become 8. 345.58 it will become, because that much of accuracy we don't want. If we have to get more and more accuracy, we have to use so many digits after this point. But here now we have used only 2 points. This much of accuracy is also more. There was no need for making this much of accuracy also. 345.58, that is enough for fabrication build. If we have to get more accuracy, we will indicate. And all fabricators, all structural supervisors, all piping engineers have to recognize how much accuracy we have to do for one job, how much of accuracy we don't want. If we don't want accuracy, we will have to avoid it. Sometimes if we take more time for accuracy, it won't have any reason. Wherever we have to use more accuracy, there we have to use more accuracy. Okay. So I think you have understood why did I write 345.58, because after 345.57 one number was some numbers were coming 5, some numbers I don't remember it, but the next number 345.57 was more bigger than 5. If it is bigger than 5, the earlier number which is coming has to be written adding 1, so it has become 8. If the next measurement which was coming there was less than 4, the earlier measurement has to decrease 1, and we had to write 345.56. But the measurement which was coming after these 2 digits was bigger than 5, so I wrote 345.58. Okay. So the perimeter is 345.58. So we have to make this kind of cylinder with 100 diameter ID, 100 diameter MD, 100 diameter outer 120, and the thickness of 10 mm. We have to cut the sheet or plate in the we have to cut the plate in 345.58 length, and its height is 200. It has been already given to 200. Its outer die is 120, its thickness is 10 mm. Here also I have 10 mm thickness. There was no need for me to indicate thickness 2 times in a job. These 2 are same job, but there was no need for me to indicate same measurement in plan and elevation. But I did it for make you teach. I had to teach you it, so I did it. Here also I have indicated 120 measurement twice. No need for me to write it 120 times. Next time I won't do it. Here I have written 120, dia 120. Here also I have written dia is 120, outer dia is 120. Next time I won't do it. Now I did it for teaching you. Okay. So if we cut a sheet or plate in this form, 345.58 into 200, 345.58 into 200. After cutting that, after cutting whatever operations we have to do, after cutting we have to grind it, we have to deburr it. These works we have to do. Afterwards we will do the work of bending or rolling. When we bend with this sheet or plate, actually we have to tell about it is plate, because its thickness is 10 mm. The thickness which is bigger than 3 mm is called plate, and the thickness which is less than 3 mm is called sheet. So it is having a thickness of 10 mm, you know it. So it is a plate. This plate, if we roll this plate, if we bend this plate, we will get a job of dia 120, outer diameter 120. Its thickness is 10 mm and its height will be 200. Okay, now you have understood it. It's a conclusion. So 3 dias I have indicated: 120, 100, 110. Both 3 plans are same. 3 plans are indicating same job. Here I have indicated about a diameter only. Just think how will be its radius. If it is 120, outer to outer is 120, its radius means radius is coming from the center point to outer surface. What is the half of 120? It is 60. I have indicated it here. It is also same cylinder whatever we have studied these days. Its outer diameter was 120. If it is 120, its radius will be 60. Half, it will be half. I have indicated it here. Its radius comes from center and it reaches in its end of the body, end of the ball. So it radius is, outer radius is 16, and its inner diameter is 100. From inside to inside is 100. If it is 100, what will be the inner radius? Inner radius comes from the center of the round, and it ends in the inside body. So if it is 100, it will be 50. I have indicated it here. From center to the inner wall, arrow end has been reached in inner wall. It is 50. It is 50. And I told about one outer diameter, I told about inner diameter, and median diameter is from the center of the thickness to the center of the thickness, dotted line to the dotted line, from here to here, it is 120. If medium diameter is 110, its medium radius will be from center to the arrow end, from center to the dotted line, from center to the center of the thickness, that is 1/10 half, it is 55. I have indicated here 55. So remember, it is inner radius, it is outer radius, it is medium radius. When we have to calculate a perimeter, we have to use this medium radius or medium diameter. Medium radius, if we use medium radius, we will have to double it, because our formula is pi d. Okay, today's class, I just close. In next class, I will be speaking about more congested jobs and more congested pattern developments. Those pattern developments won't have a shape of square or perimeter. This is very easy. It is having a perimeter, having this development and this development, both are having a shape of rectangular. Next developments won't have a shape of rectangular. It will have different, sometimes this kind of shapes it will have. It doesn't have a length, it doesn't have a width, it is not a straight line, it is not a radius type round type line, it is having different types of shapes. This kind of shapes jobs I will indicate it in coming videos. So tomorrow I will do next video. Up to that time, okay, goodbye.